Now if you look at this solution that I have right here, I have two console applications, A1 and A2, and a class library project. Both of these console applications are making use of this class library project. So if you look at the class library project itself, I have a very simple class here which is called sample, and within this class I have a static method called getMessage1 which returns a string. So all this method does is returns the string, and this class library assembly is being used by application A1 and A2, and you can see that in the references. So even in application A2 it's making use of that class library. So how are we using that class library assembly in A1 and A2? So within A1, what are we doing? We are actually invoking the sample class that is present in class library assembly, and we are invoking this getMessage1 method and printing the message returned by this getMessage1, and we are doing the exactly same thing even in A2 application. Okay, so let's build the solution. Let's open A1 project in Windows Explorer, get into the bin, debug, and within this directory, as you might expect, we have the applications executable a1.exe and the assembly on which this application depends upon, which is class library.dll. So copy those assemblies and let's move them to my application folder. So I've created a folder called my application, and I want to move both of these into this folder. So a1.exe and class library, and along the same lines I want to also move application A2 and its dependent assembly, which is nothing but class library.dll again. So a2.exe and class library.dll. So both of these applications are depending on this class library.dll. So let's copy that into my application folder. Okay, so if you look at this, these two applications rely on this class library.dll. So if you look at the presentation, we exactly have the same situation, two applications sharing this assembly. And if you look at this, both of these applications, now I run this application A1, it works fine, prints that message as expected. Similarly, application A2, it also works as expected. Why? Because both of these executables have the version of the assembly they need. Now let's say over a period of time application A2 has gone some upgrades, as a result of which we have a new version of application A2, and as part of the upgrade process they also changed the class library assembly. Maybe let's say this is a new version of class library assembly that we have, so they changed the version number from 1.0 to 2.0, and within the assembly they also have changed the method name from getMessage1 to getMessage2. Now this is a breaking change. If there is already an application that is expecting getMessage1 method to be present within the sample class, those applications will now start failing when you copy over this assembly. Let's see that in action. Okay, so let's build this assembly and let's go into the console application A2 and let's make, okay, this one is going to make use of getMessage1. Remember, we are having a new version, so this is the new version of A2 and the class library. So when I build this project, and let's go into the bin directory of this application, copy the application and the class library into our my application folder, copy and replace that. Now look at this, we installed a new version of A2 application, as a result of which it overwritten the class library.dll as well. And now when we run A2 it works fine, there's no issue. But the existing application, which is A1, it fails. It will not find getMessage1, because why? This class library.dll contains getMessage2 method right now. getMessage1 is removed, and the change for this assembly is not backward compatible, and it has been accidentally overwritten by the installation of this new application A2. as a result of which your existing application A1 stopped working. So this is nothing but DLL hell. Okay, so now let's get rid of all of these and let's see how to solve this problem. Okay, so let's put it back to how it was before. So let's go to assembly info.cs of class library. So let's make it version 1 like how it was before, and let's call this method as usual get message to 1, and let's build this class library assembly, change A2 to back what it was, get message 1. Okay, now let's strongly name this shared assembly. And how to do that? Very simple. We use the strong naming tool first to generate the key pair, the private and public key pair. Once we have that key file, we then use the assembly key file attribute and then strongly name this assembly. And if you're not sure how to do that, we already have a video recorded on that, so please check that video, because we'll not be covering the complete details of strongly naming an assembly here. Alright, so I already have the key file which is generated using the strong name tool, and it is present in the C drive. That's the name of the key file. So let's copy that. Let's get into the assembly info.cs of our class library assembly, and within that we use the assembly key file attribute. So assembly key file attribute, and to the constructor we pass in the name of the key file that contains our private and public key pair. Alright, so now let's rebuild the solution. So rebuild the solution. So what will this process do? It has strongly named this class library assembly. Alright, so now let's remove these references which were already there. So I'm removing these references, and let's clean the solution. Now you might be wondering what clean solution will do. Clean solution will basically delete all the assemblies that are there in the bin folders of respective projects. So if you get into the bin folder of any project, you shouldn't be finding any assembly. They would have been deleted. Now this is just the Visual Studio host file, which we'll talk about in a later session, but you don't find the executable or the DLL. So if you go back to the class library, even that should have been deleted by now when we said clean project. So clean project basically deletes everything, the assemblies from the respective folders. Okay, so let's rebuild the solution. Obviously we'll get errors, because why? Application A1 and A2 are referring to this class library assemblies, but we don't have a reference to those assemblies yet. So let's set the references now. So application A1 wants to use the class library assembly which is present in A1 folder. So class library bin debug class library, and along the same lines we want to set a reference to application A2 as well. Okay, so now let's go ahead and rebuild the solution once again. So now everything should work without issues. Okay, now the only difference between the first time and this time is that this time this class library assembly is a strongly named assembly. Alright, so now let's open this folder in Windows Explorer, get in the bin debug. So you have this a1.exe and the class library assembly. Let's copy these and move them into our My Application folder. So I paste them here, and along the same lines let's open application A2, open it in Windows Explorer. We are doing exactly the same thing, except that A1 and A2, the class library assembly right now is strongly named. Copy and replace. So now I run A1, it works fine as expected. A2 works fine. Now let's do the breaking change. But before we do the breaking change, mind you guys, this class library is a strongly named assembly. So this can be installed into the GAC, Global Assembly Cache. Okay, and again we have seen how to do that in the previous sessions, so please watch those in detail if you're not sure on how to do that. So I want to install this assembly into the GAC. So let's go into the Visual Studio command prompt, and we use the gak utility tool for that. So gak util -i for install, copy the path which is c:\my application, and within that we have this class library.dll, and press enter. So what should this do? This should install this class library assembly into the gak. So since this, I mean, we have built this assembly using .NET Visual Studio 2010 and we have .NET Framework 4.0, the location where this assembly is installed is actually C Windows Microsoft .NET assemblies. Remember, if you have .NET Framework 4.0 installed on your computer, you have two versions of the gak, and we have spoken about that again in our previous sessions. Okay, so let's go to c:\Windows Microsoft .NET assembly, and within that, if you go to gak msil, you should see a class library folder there, within which we have, this is built using version 4.0 of .NET, and the version of the class library assembly is 1.0.0, and this is the public key token. And if you open that folder, you should see class library assembly. Very good. Okay, now let's go ahead and do the breaking change that we want to do. Now let's say there is a new version of A2, and A2 has changed some of the things in this assembly. Let's say they did the exact same thing. They changed this method name from getMessage1 to getMessage2, and obviously they need to change the version number as well. So assembly version right now is 2.0, and let's build this assembly, and let's open this, and obviously it is expecting getMessage2. Let's build this application A2. Okay, let's open this in Windows Explorer, bin debug, copy the application and the DLL, go into my application folder, copy paste them. So now, as you might expect, it did the same thing. It overwrote a2.exe and class library.dll. Now this is a version 2 of class library, and remember, since this is strongly named, you can install this as well into the gak. Now if I run a1.exe, look at that, a1.exe will still work. Look at that, it's working, and a2.exe will also work. Because why? If you remember how .NET Runtime environment finds assemblies during program execution, it's very simple. It searches the version it requires, and if it's a strongly named assembly, it checks the gak, and if it finds it there, it pulls it from there and then uses it. If it's not found if it doesn't find it in the gak, and if there is a configuration file, and if you have specified a specific location to search for in the configuration file, it searches for that location. If there is no configuration file, then it searches in the location where the executable is present, and if the assembly is found there, it uses that. So please check that video part and you'll understand that in a great detail. Okay, now since we installed version 1 of this assembly inside the gak, so this a1.exe will find that assembly it requires in the gak and uses it, but a2.exe will not find what it requires in gak because it is present only here. If you want, you can install this also into the gak. Okay, so once we install this assembly into the gak, what's going to happen? Both the versions can live side by side. Let's actually do that. So if I say gak util install this assembly also into the gak, what's going to happen? Even this version 2 of this class library assembly gets installed. So if we go back and check the c:\Windows Microsoft.NET and assembly folder gak msil, you should see within class library two assemblies. One is version 1.0, the other one is 2.0. And even if you delete this assembly from here, your application, let's close this, both application A1 and A2 should still work. So A1 is working A2 is also working. So how are they working? Because both of these applications, what is the resolution algorithm used by the runtime environment? It first searches the GAC if it's a strongly named assembly that it is looking for, and within the GAC you have both the assemblies, class library version 1.0 and version 2.0. So strongly naming the assemblies solves this DLL hell problem. There is no accidentally, there's no chance of accidentally overwriting the assemblies, because why? Different version of the assemblies can live together side by side, and this is called a side by side execution in fact. Okay, so strongly naming assemblies